Hello friends, today we are going to discuss noise point from the subject Foundations of Communication and Computer Network. Next, what is meant by noise? It is an unwanted signal enters into an original signal and gets disturbed due to that unwanted signal. This original signal gets disturbed and errors can occur or introduced in the original signal. So we can define noise as any unwanted introduction of energy which interfere with the proper reception and reproduction of transmitted signals. Here in this diagram, from point 1 to point 2, any signal is going to transmit, and within that transmission path, so that medium, noise can added into that original signal. Therefore, the shape as well as frequency phase can change to the receiver signal. There are different sources of noise such as natural, man-made or internal. These are also called as fundamental source of noise. Natural sources can occur due to automatic movements of radiations such as cosmic noise and atmospheric noise. Man-made sources, the noise gets generated the opening and closing of high voltage current due to it induces sparks. Electric motors, welding machines, ignition of automobiles generate such type of noise. The third one is the fundamental noise. The noise generated within electronic components because of physical nature of the material. This noise generated due to specific circuit design. It is also called as internal noise. So, according to the sources of noise, there are two types of noise can be established here. First one external and second one is the internal type of noise. Some automatic extraterrestrial and industrial noise can be categorized as external noise, and thermal, short noise, partition, flicker or transit noise are categorized as internal noise. Let's discuss one by one. First one, atmospheric noise. It is generated due to the lightning and electric discharge in the cloud. Atmospheric noise is automatic or kind of natural source. Second one, extraterrestrial noise. When automatic movements or radiations in the space, such as sun or satellite, the extraterrestrial noise can be generated. The noise radiated by sun or star, it is called as cosmic noise. Next is industrial noise. It is also called as man-made noise. The noise get generated in opening and closing of high voltage or current contacts which induces spark. Fluorescent light switching gear generates such type of noise, such as welding machines also. As the receiver bandwidth increases, the amount of noise also increases. Next category is internal noise. It is originated by active or passive devices found in the communication. It is a random and difficult to analyze and treat, but it can be described well statistically. Next one is the thermal noise. It is produced by random motion of electrons in a conductor due to heat. Free electron in a conductor possesses kinetic energy. This energy gives motion to electrons. This motion is randomized due to collision of electrons. The noise created due to heat or thermal causes is known as thermal noise or Johnson noise. Next, noise power is directly proportional to temperature. One expression is given here, such as Pn is directly proportional to Tb, where Pn is nothing but maximum noise power and T is nothing but absolute temperature, and B denotes bandwidth or noise, where here we can take constant such as Boltzmann constant, which takes constant value as 1.38 into 10 raised to minus 3 joules per degree Kelvin. Next is short noise. It is caused due to random variation in current flow in active devices such as transistor, diodes, etc. The fluctuation in the number of electrons or holes constitutes such short noise. Short noise occurs because all charge carriers, that is electrons as well as holes, do not cross a potential barrier at junction. This random current flow results in noise. It is determined by the equation I is equal to I plus I0 into Q into V ampere, where I is nothing but direct current across the junction, I0 is the reverse saturation current, Q is nothing but the electron charge, and V is the effective noise bandwidth. Next, partition noise. Partition noise occurs when current separates into two or more paths. Example BJT, where emitter current is sum of the collector as well as base current. Division of current gives rise to random fluctuation. The spectrum of partition noise is flat. Next one is the low frequency noise. It is also known as flicker noise. In semiconductor devices, flicker noise arises due to fluctuation in the carrier density. Carrier density fluctuates, conductivity fluctuates, and this fluctuating voltage gets generated as flicker noise. As density fluctuates, then flicker noise generates. The next one is the transit noise, transit time noise, or high frequency noise. Transit time is time taken by a carrier to cross a junction. When signal frequency is high, then transit time is low. In some cases, some of the carrier may diffuse back to the source and generate transit time noise. Next is white noise. It contains all frequency components in equal proportion. It is the spectral density of a white noise, which is given by this equation. Next one is the noise calculations. In that first we will see signal to noise ratio. Signal to noise ratio gives us what we want actually and what we don't want. Signal to noise ratio is nothing but the average signal power divided by average noise power. We have to consider here average because they may change with time to time. High SNR means signal is less corrupted, and low SNR means signal is more corrupted. In decibel also we can calculate signal to noise ratio as by using this formula. Signal to noise ratio in decibel is equal to 10 log 10 signal power divided by noise power, which is calculated in average. Here in this diagram we can see high SNR gives low, less corrupted signal, and small SNR gives here high corrupted signal. A simple example is noted here. You can see here the power of a signal is 10 milliwatt and the power of the noise is 1 microwatt. What are the values of SNR and in dB also? The values of SNR and SNR dB can be calculated by using this formula. As we have seen just now, it is nothing but the average signal power divided by average noise power. So average signal power is converted into microwatt and average noise power is given. So in decibel you can use the same formula as 10 log 10 signal power divided by noise power, to which it is going to calculate here as a result 14. Next is noise factor. Noise factor is the ratio of signal to noise ratio at input divided by signal to noise ratio at output. This result gives as noise factor. Noise factor can be expressed in decibel. So with this formula 10 log 10 F dB, where F is nothing but noise factor. Noise temperature can be used by using this formula F minus 1 into T, where F is nothing but noise factor and T is nothing but temperature. Induced noise, it is nothing but the noise comes from sources such as motor or appliances. Impulse noise, it is spike that comes from power lines, lightning, and so on is called impulse noise. And last one is the crosstalk. It is the effect of one wire on the other when they are connected with each other. In this way, we have seen different types of noise and different formulas with examples. Okay, thank you.